Solving trig equations. Yeah, let's get into it. Now we're going to mess around. Again, we'll do all the solutions, but we're also going to look for just values between 0 and 2 pi. That's the game we'll typically play with you. Just find the answers between 0 and 2 pi. So no positive angles and no angles bigger than 2 pi. Let's jump into it. So here's just a simple problem I got set up. So it says we're going to solve in two different ways. The way the game I like best, just finding your angles that are in between 0 and 2 pi. Actually, I wrote this in. Let me write this in a little bit different. Because typically we don't want this. We don't want the 2 pi. Let me change this back up here too. That's a little better. We're not going to include that endpoint. We're going to think of 2 pi as the same thing as 0. Okay. So let's get it. So we're going to need to solve this equation here. Right here, we're going to solve that equation. So what we're going to need to do is get everything over to one side. So we can play the same game we did before. Remember, we had cosine of x was equal to a half. Well, now we're going to need to set it up. So our game is going to be, take this, and we're going to want to move this sign over to that side. So we can get all of our trig functions on one side and their numbers on the other. Just like you would perform algebra, right? If you were to have root 3 minus x is equal to x, you'd be like, add x. You got root 3 is equal to 2x, divide by 2, and x is equal to the square root of 3 over 2, right? Is that how you do algebra? What we're doing. That's the same shit that we're doing here. So we're like, dude, just add over the sign, add the word. So that word plus that word gives us 2 of that word, right? It's equal to the square root of 3. We divide by 2, and we find out that root 3 over 2 is equal to sine of x. Well, dope. Now we're right back to where we were when we were messing around with our last problem, where we had cosine of x was equal to a half. We just need to go figure out first. Now let's start off with the idea of the reference angle. Since this is a positive input, this root 3 over 2 is a positive input, and we're dealing with sine. That means we have an angle somewhere in the first quadrant, and we have an angle somewhere in the second quadrant that would make this true. Because sine is positive in the first and the second, negative in the third and the fourth. So we know that our two angles in between 0 and 2 pi must be in between 0 and pi, because that's where sine is positive. So, since this is where it's positive, we go in, we're like, dude, just what the frick is the reference angle? Let's start there. What is our reference angle? What makes sine of what angle is pi over 3? And we're going to... Sine of what angle equals root 3 over 2? And that's pi over 3. We found our reference angle. I start with that one here just to look, because sometimes you're going to have a negative value and the reference angle won't be the answer. But it happens to be, since in the first quadrant, there's our answer. We can say that, yes, x equals pi over 3 is one of our solutions. Now we just need to look over in the second quadrant and figure out what angle also has a reference angle of pi over 3. And come on. We're in the second quadrant. We can do one of these games real quick. Be like, I wonder what 3 pi over 3 minus pi over 3 might be. And that is x is equal to 2 pi over 3. These are the only two values in between 0 and 2 pi of x that would make this equation true. They are the only ones that will make this equation true. In between 0 and 2 pi. But if we remember from before, so this is for A, if we add 2 pi to any one of our answers, because we're dealing with sine, we're going to continue to get the same output. So we could say x is equal to pi over 3 plus some 2 pi. I usually write k, but they use n, so I'm going to continue to use this. And x is equal to 2 pi over 3 plus 2 pi n. We will get those two solutions. I still need to define what n is just by writing in n. That's not cool. So I'm using your fancy math there. N is an element of the integers, positive and negative numbers. So just again, if we don't know, just some examples of them. ... like maybe -3, -2, -1, 0, 1, and it goes on like that forever. I'm running out of room. whole numbers, positive and negative. It doesn't matter how many times you spin around in the circle, you end up right back where you freaking started. Huh? Whether I add 2 pi to this or I add 10 pi to this, if it's an even amount of pi's, I'm going to end up right back where I freaking started. And that's why this works. So for part B, you're pretty much done. You might have some homework with it, but when I ask you on your exam, I'm going to ask you for 2 values in between 0 and 2 pi. And not all of them have 2 values between 0 and 2 pi. Some of them only have 1. Shit, you're going to find equations that there's no solution to. So this is our game. I'll be back with more.